Hey everybody, Mr. Dickin here. In this video, we're going to talk about graphing systems of linear equations with the hope to find the solution. So here I've got two separate systems, and we're going to go ahead and graph each of these systems on the provided graphs. Fancy, fancy. And then we're going to see where they intersect. The point at which they intersect will be our solution. So we'll write it as a coordinate x, comma, y value. So let's take a look at the first one. First problem, I've got y equals negative 1/3 x minus 2, and y equals negative 5/3 x plus 2. Well, right out the gate, I'm noticing the slopes are different. Right? Negative 1/3, clearly not the same as negative 5/3. If the slopes are different, then we're not going to have parallel lines. And if our lines are not parallel, then we know there's going to be some sort of intersection point. So let me graph this first one here. We have negative 1/3 x minus 2. So my y-intercept is going to be negative 2. I'll put a dot on the y-axis at negative 2. Make sure it's on the y-axis, never the x. And then my slope, negative 1/3. That means I'm going to go down 1 over 3. And just like a book, we read it left to right. Down 1 over 3 to get my next point. So now I've got 2 points. Now let's say, hypothetically, maybe I want more. I'm running out of graph if I go this way, right? Down 1 over 3. But I could go backwards. Instead of down 1, right 3, I can go up 1, left 3, up 1, left 3, until I get some additional points there. As soon as you have enough to graph your line, use a straight edge, or if you're doing this online, which most of you will, as soon as you have 2 points, it'll automatically go in there for you. All right, let's grab the second one. We've got a y-intercept of positive 2. And then my slope is negative 5/3. So I'm going to go down 5/3. So it's looking like right there is going to be my intersection point. Down 5/3. Again, I've got 2 points. As soon as you have 2, you can connect the dots with a straight line to the best of your ability. Awesome. And we found our solution. So that would be 3, negative 3 is our solution value. So 3, negative 3. If we solve this using algebraic methods, substitution or elimination, you should get the same exact value. All right, next one. X minus y equals negative 4. And 4x plus y equals negative 1. These equations are written in standard form. Standard form is great for finding x and y intercepts, and that's about it. All right? It doesn't really have direct graphing advantages unless you're trying to find intercepts. The way you would find an intercept is, we'll use the second equation for example, 4x plus y. If I wanted the y-intercept, the x value would be 0. So if x is 0, this whole term would be canceled, so I'd just have y equals negative 1. To find the x-intercept, the y value would be 0, so I'd ignore this term of y, because that'd be just 0, and I'd have 4x equals negative 1. Solve for x, I'd get negative 1/4. The problem with doing the intercepts is sometimes you might get weird fraction answers, and fractions are hard to graph, because you have to estimate. So we're going to rearrange these into slope-intercept form. The way we do that is we get y all by itself. So for this first equation, I'm going to move the x to the other side first. So I've got negative y equals, it'd be negative x minus 4. Not too thrilled about that negative y, so to change that to a positive, just divide everything by a negative 1. Essentially what's going to happen is any negatives turn positive, positives turn negative. So that's going to be the line that we graph. 1x plus 4. So let's graph that. Y-intercept of 4. Slope is up 1 over 1. I'm already running out of room, but I can go backwards, down 1, backwards 1. As soon as you have sufficient points, connect the dots with a straight line to the best of your ability. Cool. All right, let's get into the second one. Same thing, I want to move the x value over, so I'll have y equals, there'll be negative 4x on the other side, minus 1. And hey, we're good. All right, I don't really need to do anything more. Sweet. So let's graph that. We've got a y-intercept of negative 1. A slope of negative 4 is technically negative 4 over 1. So I'm going to go down 4 from this point, down 4 over 1 to get this point right here. Or I could go backwards, right, and go up 4, backwards 1 to get that point right there. As soon as you have sufficient points, grab your straight edge, connect those with a straight line. All right, so I'm seeing the point of intersection. This guy right there. So we've got a point of intersection at, what is that? Negative 1, comma 3. And just like before, if you were to solve this thing using elimination, and it's perfectly set up for elimination, right? The y's would have canceled. You'd get 5x equals negative 5. Solve for x. Boom, you're going to get negative 1. Plug negative 1 back in for x. You would get 3 for your y value. All right, so now you have 3 different methods in your arsenal to solve systems. You have substitution, elimination, and graphing. If you have any questions, let me know. And as always, folks, good luck, have fun, be safe, roll tide.